Good afternoon, students. Today we have to learn about the energies and the motions. Today's our topic is about the work and the energy. So first of all, we have to know about what is meant by the energy, what is meant by the work. Work means what? Yes, doing something or doing and some action is known as the work. And the main thing and the main part is the energy. Energy means the capacity of a body to doing and work. Means what? For doing and some work we required or we have some energy to do that work. So this is known as that is known as the energy. Okay. So what do you mean by the energy? The capacity of having a body to do the work is known as the energy. Okay. There are the different types of the energy is there, like mechanical energy is there, mechanical energy is there, electrical energy is there, potential energy, kinetic energy, different types of the energy is there. Today we have to learn about the kinetic energy, So what is mean by the kinetic energy? What is mean by the kinetic energy? Before going towards that kinetic energy, I am going to give you some examples. You have to identify which type of the example is there and what is going on or what we have understand related to that or about that expressions or about that examples. So first example is there, the running ball that we have playing of cricket. Okay, so running ball strikes and a stump. Here the ball is running and the stump is stationary, right? Second example is the coin or the striker strikes the coin on the carom board. Here striker is in moving position and the coins are in stationary objects, stationary thing. Okay. Now the third example is about the marble playing game. Means one marble, we are throwing the one marble to the remaining marbles. Okay. So here also one marble is in moving position or in the position or in the motion, and the others are in stationary object. So what we learn about that in all the examples, one object is stationary and other is in moving position or in motion. So means what? By applying that position or by throwing that object towards the stationary object, the motion that moving object has, it transfers its energy to the stationary object. So that also get energy and it gets shifted or its position get out the changing. Whenever we strike the striker on the other coins, that coins are also moved towards other side. So means what? They are taking that energies from that moving position or moving object thing. Okay. So what is the definition of the kinetic energy? Definition of the kinetic energy is that the energy of the motion that we are getting from the object is known as the kinetic energy. Means what? The energy that the object has because of its motion, is known as the kinetic energy. The energy that the object has due to the motion is known as the kinetic energy. So this is about the kinetic energy. As the energy have the unit joule and the CGS unit is earth, similar way the kinetic energy also have the unit, but it is measured in terms of the joule and the earth. Okay. We know that work done is represented by, or work done is denoted by W, which is equals to F force into displacement. Similar way, the kinetic energy is also equals to the work done. That is, KE is always equals to W. Means what? The kinetic energy is always equals to W. Means kinetic energy is equals to the work done. If as work done is equals to Fs, that's why kinetic energy is also equals to F into S. Okay, means what? Kinetic energies and the work done are in equal form, or they are equal to one another. Okay, so today we have to learn the motion of the expression for the kinetic energy. Okay. Before using the expression or before finding the expression for the kinetic energy, we have to know about what is mean by the motion. So what is mean by the motion? Motion means the changing in position or the things that is in position, that change its position, then that we can say that thing or that object is in the motion form. Okay, means the moving thing is known as the motion. Okay, So these motions, according to that motions, Newton's obeys or Newton's discovers the three law of motion. That is law. First law is, that is Newton first law. Newton's first law. Second one is Newton's second law, and the third is Newton's third law. So according to the Newton, there are mainly three laws of motion: first law, second law, and the third law. Every equations or every laws have the different laws that obeys the Newton's three laws. First law states that we all are familiar with them, but for a revise we will take them. Okay. Newton's first law means it obeys that every object is continuously in its rest position until we cannot apply any force on it. Suppose if this chalk I kept here, okay, it will be till here on today also, after 1 hour also, after 1 day also, after 2 days also. But whenever till what time it will be remain this position, until I am not taking it up or putting it up or moving here or moving there. Okay, means what? I am applying a force on it. So Newton's first law obeys that any object can be in its rest position till we cannot apply any external force on it. Okay, so this is the Newton's first law. What is the Newton's second law? Newton's second law gives the relation between the force, mass, and the acceleration. That is, its equation has become F is equals to ma. Third law, and the very easy law, is that we all are familiar with that. To every action there is an equal and opposite reaction. There are many examples that obeys the third law. That is the throwing a ball, sailing on boat on the river. All are the example for the third law. Okay. So for obeying or for performing the kinetic energy expression, we required or we need the Newton's law. Okay, mainly we have to obey the Newton's second law, or we have to use the Newton's second law. According to that, mainly there are the Newton's three motions equations are there. Three equation of motion is there. First equation is V is equals to U plus AT square. Okay. Second one is U V square is equals to U square plus 2AS, and the third equation is S is equals to UT plus 1 by 2 AT square. So these are the three equations of the motion. First is V is equals to U plus AT. Second one, V square is equals to U square plus 2AS. Third one is S is equals to UT plus 1 by 2 AT square. So these are the three Newton's equations of the motion, for the motion. So for obeying or for producing the kinetic expression for the kinetic energy, we have to use the Newton's second law of motion. Second equation of the motion and the second law of the motion. Okay, so what is that we have to learn today? Okay, so let's start. We will remove this. Before that, let's suppose and one stationary object is there. Okay, one stationary object is there means what? It has some, suppose this duster, this is the stationary object, but this has some mass, and we consider the mass m. It having the mass m, and if we apply, because we applying a force on it, so it has some force that is denoted by the letter F, and it has the two velocity, that is the initial velocity also and the final velocity also, we learned in the previous session. Okay, so it has the initial velocity, that is u is equals to, will be always 0, means what? The initial velocity is always will be a 0, so it has the initial velocity that is equals to 0. But if we apply the force on it, so it consists of the force that is denoted by the letter F. Now this generates an acceleration, or it generates the acceleration A in the object, and after time t it will change its position also. So we have to use here Newton's second law. What is the Newton's second law? F is what we are applying some force, and the object has some mass, and the acceleration are producing or applying on that. So we are using the Newton's second law. F is equals to m into A. This is the Newton's second law of motion. Okay, according to Newton. But we all are familiar with that work means W. Why we are taking the W? Because we know that the kinetic energy and the work done are equals to one another. So work is equals to F into S. This is your equation number 1. Okay, and we all know F is equals to ma. So we have to put that value in this equation. But we did not have the value of S. So we have to find the value for the S. Okay. So for finding these values, what I told you, that we have to use the Newton's law. So Newton's second law equation we have to use here. And what is that equation? S is equals to ut plus 1 by 2 at square. Right? S is equals to ut plus 1 by 2 at square. This is the Newton's second law. Okay. But we all know that I told you that this duster having some mass m, but it has some initial velocity that is equals to 0. So means what? The value of u is equals to 0. After putting this value u is equals to 0 in this equation become S is equals to, on the place of u we will take here 0 into t plus 1 by 2 a t square. Means this term will become cancel out due to the 0. This will become the 0 value. So S is equals to 0 means nothing, 1 by 2 a t square. This is the value for S. But we have to find the value of the t also. So from where we get that? So for this we have to use the Newton's first law, that is V is equals to u plus a t. Right? This is the according to Newton's second law. We have to use here the letter of the things. Okay. So if we know that u is equals to 0, after putting this value u is equals to 0, this equation becomes v is equals to 0 plus a t. Means 0 will be cancelled out and v is equals to a t square. A t. Now if I am going to square it, Why I am going to square it? Because we have to put here the value of 80 square. Okay, so that's why I am going to squaring here. So both side, by squaring both sides we get v square is equals to 80 square. Okay, so we get the value of 80 square. So that value we have to put here in equation number 2. So equation become S is equals to 1 by 2 v square. Now we get the value of S, and that value we have to put in our final equation, that is equation number 1. So it becomes W is equals to F into S is there. So W is equals to F means M into A into S value. What is the value of S? 1 by 2 v square. Okay, 1 by 2 v square. So this is the value that we get here. Okay. Now after that we have to put this value in the equations and we get the value of equation. So we get the value W is equals to 1 by 2 mv square. Okay. Why this A is not here? Because after here we get the value of A square t as a v square. That's why whole value of 80 square is equals to v square, means we get m into 1 by 2 v square. Okay. Now after that, W is equals to 1 by 2 mv square. This is the equation for the W, but we all know that kinetic energy is always equals to W. That's why if W is equals to 1 by 2 mv square, therefore kinetic energy is also equals to 1 by 2 mv square. This is the equation, or this is the expression for the kinetic energy. Okay, so today we learn about the expression for the kinetic energy, or what is the equation or what is the expression for the kinetic energy. Kinetic energy is always equals to 1 by 2 mv square. Okay, for this, performing this, we use the formula, we use the equations, or we use the Newton's second law of motion, first law of motion also. The work done is always equals to the kinetic energy. And what is mean by the kinetic energy? Kinetic energy is the energy of an object through its motion, that gets its motion from its position or from its motion, is known as the kinetic energy. And kinetic energy is always equals to the energy, means it always is calculated in the form of the energy unit, means the erg or the joule. Okay, so this is your today's session. We learn about the kinetic energy.